Good morning to one and all present here. It's a pleasant and happy occasion that we are gathered here for the guest lecture on the topic of network programming and management. I'm very glad to invite Dr. B. Anand Kumar, Professor HOD of Department of Computer Science and Engineering from Madras Institute of Technology. I extend my HOD, Department of Information Technology. I also welcome my friends to this guest lecture. I would like to share some achievements of Dr. B. Anand Kumar. His area of interest is in networking, digital image processing, artificial intelligence, multimedia data structure, and so on. He has published 34 international journals and attended 13 national conferences. Under his guidance, 10 PhD awards were given. Now, I invite Dr. R. Prabhu, our HOD, to honor the guest with bouquet. Thank you, sir. We are looking forward to our guest lecture.
Correct. So whenever the committee comes, even today the committee is coming from the university. Whenever the committee comes, they used to ask what is beyond the syllabus coverage. Okay. So I feel that it is more appropriate to take something which is very recent and which is useful for continuing the research and academic activities. Okay. That way, with that context in mind, I decided to give software-defined networking as a course. Actually, this is not that much. This is an upcoming field. It is not popular. It is not. It's an upcoming field, just like big data, cloud computing, and in the networking field, this is a recent trend. So we'll discuss about what is SDN, background, and OS for networks. So we'll discuss about open flow software, how it helps for SDN, the current status and the future of SDN, and finally the conclusions. So we'll be discussing about the requirement for SDN. We'll be discussing about the definition and the requirement for SDN. So SDN is all about software-defined networking. So the current, if you look back 20 years or 30 years before, so the computer networks started, you might have studied ARPANET and all those things. The primary focus was to connect how best we can connect two or more computers. That was the idea behind computer networks. Okay, that trend continued for more than 5 years or 6 years, okay, but less than 10 years. Later on, it migrated from computer networks and various protocols they developed, various standards they have come up, like IEEE standards and various standards they have come up, okay, and so on. Later on, the computer networks have been transformed into what? How the computer networks were transformed? The computer networks were transformed into data communication networks. Okay? So the data communication networks are the backbone for any IT student. Data communication networks are core and fundamental and backbone for any information technology scientist. Okay. So in the case of earlier computer networks, they have given primary importance for file sharing kind of activity. They don't look what is the content. Okay, they don't look what is the content. So instead of they concentrated more on as a file. Okay, most probably to the maximum of as a packet. So in the computer networks, they concentrated as treating it as a packet. And they don't look much inside. Okay. In the case of computer networks, Later on, they migrated to data communication networks where they modify the network standards and practices for the benefit of communicating the information. Okay, for the benefit of communicating information. In specific, the computer networks were looked at. The computer networks were looked at as a communication extension of ECE product. That was the assumption 20 years before. They looked as an extension as a communication thing. Okay, so except connecting the headphones or the normal phones, voice communication have been extended. Okay, voice communication have been extended for computer networks. That was the original long back, the trend which was present long back in the initial stage. Okay, one example is earlier the communication itself was an analog communication. Earlier the communication itself was an analog communication. You might have heard about the PNT lines, post and telegraph lines, where the analog communication taking place. For quite some years, okay, even till 1998, we used to have that modem kind of connectivity. Okay, 64 kbps, some kind of modem kind of where Satyam and other companies are very popular in giving that kind of modem. So computer requires a modem in order to connect to the other end. That was the trend. You can use a phone line. Still it is in practice, but there is a paradigm shift. Okay. In the case of earlier, they have used voice communication line for connecting computer. Okay. That was the major aspect. Later on, okay, even until 95 and so on, till then, okay, that was the period we were graduated and we were using internet and all those things. That time, even I was given training in a star hotel how to use internet. You may wonder, okay. Now even a child is capable of doing their experiment, completing their assignment, completing their assignment with the help of internet and so on. There is a technological, we have to thank the technological developments happening. So analog communication, then it becomes suitable for digital communication. There is a scope for considering computer networks into data communication network. So for the implementation of data communication network, digitization of channels were important. Digitization of channels. So exchanges were become digitized. Telephone exchanges were become digitized. Lot of service providers were coming to the practice. So all are focusing exclusively on how best the data could be communicated in a digital. What we are having today is a digital communication era, and apart from that, with the advantages of mobile and other things, there is a scope for communicating the data through the mobile and other wireless links. Okay, earlier we used to see microwave links very rarely. Once in 6 kilometers or so, according to their curvature, they used to keep microwave towers. Okay, that too meant for some high-end communication purposes. But now the trend has changed. Even within a smaller area like Avadi or so, you can see number of microwave links. Or I mean that wireless towers. Okay, so all are microwave links. Of course, the power difference will be there. Power handling difference will be there. Still, high-end microwave links are also available. You can see the high-end, the height of the link antenna will be very high. Height of the antenna is very high. Are you able to follow me? So earlier it was computer networks with the help of with the help of analog communication, including digital data will be converted as through the analog. Okay. Earlier they used to say modem means converting analog data to So converting digital data to analog, some DTA converter and communication modulation thing will be there, and the data will travel in the form of analog form, earlier. Okay. 15 years before, or up to during the previous decade. Then they migrated from analog to digital. Digital made it possible. Okay, digital exchanges were constructed, and which made it possible to have a kind of direct digital communication. Now we are not doing a kind of analog, digital to analog. Computer works in the principle of digital. So this digital signal need not be converted into analog form. Okay, there is a major paradigm shift happened. So with the advantages of digital communication, there is a scope. So more number of internet users are coming to the as well as the almost the technology of mobile also has transformed the entire society, and large number of mobile users were also there. So digital technology has evolved, mobile technology has evolved, and digital wired communication become completely wireless mobile digital communication. Am I correct? So we are in the era of mobile digital communication. Okay, we are able to, the very good example is we are able to connect from your mobile phone to internet. Okay, you can connect internet through your mobile phones, which made it possible. And again, the spectrum, 2G spectrum, 3G spectrum, all those spectrum level analysis is also being under consideration. So I explored about the first level of communication and the second level of communication, and third level of communication is all about the advantages of computer science itself. Advantages of computer science itself. Okay. So communication people have come up with a new solution, and with the help of communication technological growth and computer science, lot of changes are happened in computer science, and with the advantages of mobile and other things and so on. Almost all the users are transacting a kind of multimedia information. We agree with that? We agree with that? Earlier the phone, the cell phone is a good example. Earlier the cell phones were used only for voice. Earlier the cell phones were used only for exclusively for voice. Now we are using cell phone for the purpose of accessing your internet account, Gmail account, and other. It becomes a smartphone. Now we should not call it as a cell phone. It is a kind of smartphone. Okay. Okay. Why I am telling is, in the third level of paradigm shift, earlier it was analog, then it was digital, now it is multimedia communication. So while framing the syllabus, we used to say earlier it was a computer network. Later on it became data and communication network. And now the communication becomes multimedia communication. Okay? How it is different? How it is different? In the case of, as I told, the advantages of computer science, made tremendous change in the sense that they have come up with different data types. They have come up with different file handling mechanisms. So earlier it was very few. Now if you go and see the encyclopedia of file formats, not less than 20,000 to 30,000 file formats will be there. Not less than 20 to 30,000. That kind of encyclopedia of file formats are there. So so increasing the number of file formats, increasing different data types made the evolution like multimedia communication networks. Okay. So in the case of multimedia communication, different data types and different file formats were in force. Different data types. Earlier it was only a binary data, very simple data. Now it becomes all kinds of, we are capable of handling all kinds of multimedia data like audio, video, text, and music, speech, and different tracks and so on. So now the communication industry is being dominated. Now the communication industry is being dominated by multimedia communication. Okay. Now the communication industry is being dominated by multimedia communication. So they are forced to handle different data types, different file formats, and so on. Accordingly, different encryption standards, decryption standards, and all those things. One very good example is even if you take cell phones, everyone is using. Okay? And if you take ATM machines, ATM machines have come up with fingerprint analysis. So they are unavoidable. Okay? So multimedia is unavoidable substance present in everyone's life. Multimedia is an unavoidable substance present in everyone's life. You take an example of this presentation, or you take an example of mobile phone, or you take an example of ATM machines, or in any context. So if anyone could live without multimedia communication, it is highly impossible. It is highly impossible to understand the world without multimedia. Okay. So how multimedia influences in one way different data types, different file formats, and so on, which poses severe challenges for the communication analyst and information technology scientist, in the sense that IP versions are changed. Okay, IP versions are changed. Okay, which IP version we are using now? Correct. V6. Okay. So what is the major changes present in the IP version 6? What is it compared to IP version 4 and 5 and so on? What is the major advantages of IP version 6? So they have extended the address. So IP version 6 have been designed in such a way that it is capable of accommodating more number of users, tremendous users. IP version 6, there are only two major advantages. One is IP version 6 is designed for multimedia. IP version 6 is designed for multimedia and multimedia data types. Second one, IP version 6 is designed to accommodate more number of users. Earlier it was limited. Number of users are limited in the IP version 4 as well as 5 and so on. IP version 6 is capable of accommodating more number of users. These are the only two major advantages. Okay. Of course, other advantages and specification changes are there. These two are into major consideration. Okay. So the multimedia made tremendous changes in communication networks. Okay. So it becomes now the communication network. So if you take communication network, it is capable of handling the data in digital or analog. Digital, correct? Am I correct or not? It is capable of handling the data in digital. Because the advantages are there, disadvantages are also there. Okay. What would be the advantages of digital data communication? What are the advantages of digital data communication? Tell me a few advantages. Or tell me the disadvantages. If you have come up with advantages and disadvantages, it is very pros and cons. Anyone can answer and you will get a reward from your organizer.
It can explain only the initialization and position between them before explaining the
Listen. So a nice answer I got. So digital manipulations are possible. Okay, handling of the data in digital form and manipulation of digital data through computer is so easy. Direct. So we don't require A to D converter, explicit A to D converter, D to A converter. All those things are not required. So it minimizes the time of handling the data. So all the real-time processing is possible. All the real-time online processing is possible in the case of digital. So you will get a very quicker and very quick response. Response time is more important when we are discussing with respect to the real-time streaming protocols. Okay. For example, those things are required for your Skype, for your other video sharing mechanisms, for moving with, for watching cricket, online cricket watch. okay, watching the shows. Okay, whether it is meant for entertainment purpose or it is meant for watching the how the satellite progresses. Everything could be made it possible through the digital way of communicating and handling of things. Okay, information technology scientists made it possible. That is the advantage. The complete. So even in the now the technology we speak like Internet of Things. Okay, now we are in the era of Internet of IoT. IoT is catching up. Internet of Things. Okay, everything is completely controlled through smart world. Okay, that is the product. That is the outcome of Internet of Things. The biggest what are the other advantages? Say encryption, we can enforce a lot of encryption standards, decryption standards, security is made possible. So with the help of, you can fully explore the possibility of computer way of handling the data. Data could be handled in number of, we can make it more safe, secure and so on. Secure way of communication is possible. High-end secure way of communication is possible. Okay. Apart from that, what are the disadvantages of digital communication?
Explain only the initial and the ending part only, not explain the middle part.
So you are telling about the sampling criteria. You might have studied about the Nyquist sampling criteria. Okay. So as per the what is Nyquist sampling criteria? Might have studied, correct? In your syllabus. So if the signal is not sampled properly, the signal may get interleaved, okay, or interleaved the signals may be present, or in the other sense, say the analog communication, analog signal, it is continuous one. Digital communication is discrete one. So the in-between data will be missing. For example, in the case of image, to take an example of image, the continuity of among the pixels may be missing if the resolution is poor. In the audio signal, so it may you may get a smaller time delay in between, so which may make the clarity of the, which may affect the clarity of the audio signal, speech signal. Okay, are you able to understand? So the disadvantages are like, but it is. I am not saying that it is not possible to overcome. It is possible to overcome the disadvantages by means of increasing the resolution, increasing the standards of sampling practices and modulation techniques. So the thing is, ultimately increasing the resolution poses other challenges like handling of more amount of data. Handling of more amount of data. If you increase the resolution of signal, resolution you might be knowing that. Okay. Are you able to understand? Resolution is nothing but the screen size. Okay. If you click the properties and you can see the resolution of screen, resolution of monitor, and resolution of resolutions are which gives the quality, which describes the quality of displayable signal. Quality of the displayable signal. So increasing the resolution causes more amount of data. So we are bound to transmit more amount of data. So which causes other challenges. Which causes other challenges. I told multimedia is dominating or multimedia is influencing communication network because all the challenges of multimedia have to be handled, need to be handled. All the challenges of multimedia need to be handled. Earlier it was only digital data, sharing of file. Okay. For example, your email application, which is nothing but just a file sharing. Okay. So your synchronization issue will not come. Synchronization issue will not come. Okay. Delay among the data type will not come. For example, audio and suppose if you are considering about the synchronization issues, audio and video need to be synchronized. Which one will travel faster? Audio or video? Audio, because of lightweight. Video signal may consume more amount of time. So audio signal will reach at well before the video signal's availability, presence. So at the customer domain, the audio signal and video signal need to be synchronized. Lot of caching mechanisms are proposed. Now, as per the latest technology, we have been going towards usage of cloud computing. Okay, cloud-based streaming is becoming popular. Which will be more helpful for streaming of content from one end to the other end. For example, very good example is your YouTube. Okay, YouTube is the very good example. Am I correct? Okay, in every minute, 24 hours of video is being recorded. In every minute, uploaded. So that means amount of video signal is being handled, or video signal is being dispatched. In the sense that so large amount of information is being handled every minute, every second and so on. So we are forced to handle that much of information. The question is whether that much of complexity level could be handled by the current multimedia communication network, or is it requiring any other solution beyond that? People have changed, made analog to digital. They made a change. They made the changes in IP versions. They made changes in packet size, all those things, packet formatting, all those things. Okay? They made changes in routing mechanisms and so on. Routing algorithms made us very physics class algorithm, various graph-based algorithms made us very. They made changes in almost various domains, routers, switches, signal itself, handling of the data types, different data types, synchronization issues through operating system based caching, okay, memory based synchronization. Okay. For example, video signal will arrive late, audio signal will come well before. They will save the audio signal first. Whatever the signal comes, they will store it. Then audio signal will also come. They will put all the audio signals and they will store it in local smart disk, and from there it will be streamed or displayed. Do you agree with it? Okay. Lot of other arrangements are being taken care of in order to consider or attempt the synchronization issues. Even one nearly produced 12 PhDs. So among the 12 PhDs, one PhD the person handled exclusively on synchronization issues, multimedia synchronization issues, for improving the quality of service. Okay. Now what we are doing earlier, okay, that person completed 2 years before. Now what we are doing is cloud-based multimedia streaming. Okay. So existing streaming solutions based on earlier we assumed all the communication parameters. So we were trying to settle, okay, with the help of better caching mechanisms or operating system kind of substances in the client side, in the user side. Are you able to understand? So I have explained about analog communication, simple computer networks, then data communication network, then multimedia communication network, and the challenges behind the multimedia communication network, how we have to be, how best we can equip ourselves for the betterment of future technology. That is nothing but software-defined networking. So earlier it was computer network, then next generation is data communication network, and next generation is multimedia communication network, and current at least your brother and sister or your son and daughter will be reading only that software defined network. Okay, in less than within 15 years or 20 years, it will replace the entire trend towards software-defined network. Okay. So hope you understood the need for software-defined networks. So here they modified the signal from analog to digital. They modified the information handling mechanisms. Okay. Then they modified. They made communication channels from analog to digital, and various communication mechanisms are changed, including wireless communication, mobile communication, made that kind of communication channel related things they performed. Then routing mechanisms are derived, and switches are defined, like active switches, passive switches, and so on. Intelligent switches are also there. Okay, what are the active switches? What do you mean by active and passive and intelligent switches? What is a passive switch? Passive. Okay? So passive in the sense, pardon? So passive switch you can actually while constructing our laboratories and so on, even passive switch it's almost obsolete nowadays. Passive switches are cannot make any decision. The simplest sentence. Okay, cannot make even a simple decision. Okay, the data comes, it will dispatch. Otherwise, it will keep quiet. Okay. Active switches, we can understand the where the signal to be delivered. Okay, where the signal to be delivered exactly, as well as it is capable of making a smarter way of switching. Okay. So we use the terminology called free rider. Okay. Free rider in free rider, there is a terminology. Free rider is capable of only downloading. They don't upload or they don't do any kind of networking activity, wireless communication field. Free riders are capable of downloading the substance only. It is equivalent to passive switch. Okay, we cannot go beyond or make some simple decisions here. Okay, adaptiveness is very less in the case of passive switches, or zero in the case of passive switch. In the case of active switch, adaptiveness is there. Okay. In the case of smart switches or intelligent switches, which are capable of making intelligent decisions, capable of instead of looking the node as a free rider, the node can act as switch, or node can act as router, or node can act as guiding the signal to the next end problem. Okay. So active switches are there, passive switches are there, active switches are there, intelligent switches are there. So for the artificial intelligence techniques are applied for the creation of intelligent switches. Okay. So the thing is, we can the difference between active and intelligence. So difference between passive and active is, passive is simply they deliver or they don't. In the case of active, it is capable of understanding the signal and making routing into the right direction in a smarter way. Okay. In the case of intelligence, intelligent principles are applied to make it better. In other sentences, difference between active and the intelligent switches. Active is intelligent switches are proactive. That is the difference. Okay. Proactive is nothing but self-initiation will be there. Okay. Self-initiations will be there in the case of proactive. Suppose if some of the routers are not, the congestion happens in one of the routers. This particular router will, a switch, intelligent switch, will share the load. Load sharing among the routers can happen. Okay, if you are, for example, if 3-member project group is there, if one of the members is suffering, then the other 2 members can act as a proactive member. Okay, so that they can try to help the other student. There is a proactiveness. Proactiveness is all required, not only in switches and routers, but also for our normal life. We have to be proactiveness. Okay. But for example, organizing the lectures is, the university is not compelling the authorities to organize the lectures and so on. University people are not forcing. From the university syllabus completion is sufficient. From your institution, you have been organizing guest lectures and various other interactive substances, which is nothing but which comes under the category of proactiveness. Okay. Active is all about completing the syllabus. That is sufficient. And adding few things. Proactive is all about adding beyond the curriculum activities proactive. So proactive nature is available either in the switches as well as in the general practice. So passive, where if you give the load, they will do. Otherwise they don't do anything. There is a passiveness. Okay. Active is all about capable of taking some simpler decision. Intelligent switches are capable of making capable of making the network connectivity more better by means of load share, by means of shortest path, by means of handling the content with more secure way and so on. So all about, so of course routers and switches can be intelligent in the sense that how best the efficiency is measured in terms of the speed in connectivity, routing, speed in routing, as well as the secure way of connectivity. These two things are comes under the category of intelligence. Intelligent switches are capable of making it more secure and more high speed. Okay, in the sense that efficient way of load sharing as well as efficient way of moving the data to the other end. Do you agree with it? So, passive switches are there, active switches are there, and intelligent switches are there, meant for a smart way of handling or moving the data from one end to the other end. Okay, are you able to understand? So, as per the latest technological trend, it has come and they have implemented a lot of graph theory algorithms, routing algorithms. They made routers and switches more intelligent and so on. But biggest some few drawbacks are there. The routers are acting independently. There is no centralized controlling mechanism, or you can ask why the centralized controlling mechanism is required. Why the centralized controlling mechanism is required? The thing is all are powerful, but okay, all the routers, all the switches, all the internet service providing mechanisms are so powerful, but they are not working in a coordinated way. They are not working in a coordinated way. So that is the first reason behind going for software-defined network. So this is the limitations of current network. These are all limitations. These are the, you can see how the dissemination of data taking place. Okay, so internet routers are there, then firewall, then core switches, from the core switches, so distribution happens and it reaches for various applications like video, so different types of components. Different types of components are connected to a switch, and from the switches it is connected to the core switch, and from the core switch it is be connected to the internet service provider, and it is nothing but making of computer networks to a level of local area network. Then what is next? Wide area network, then metropolitan area network, then what is next? Local area network is there, metropolitan area network is there. Local area network is all about connecting only this particular campus. Local area network, then metropolitan area network is connecting within the city, for example. Okay, city kind of connectivity. Then wide area network, which connects around the globe, connecting multiple cities. Okay, it is nothing but an internet. Okay, so this is the configuration available, and these are the substances available. And I have mentioned and pointed out few drawbacks of the existing system. In the case of all the switches and routers, they are following a hierarchical setup, but control is not there. All the switches are acting independently. When the data is given, it can disseminate to the other end. Whether it is IP phone or video conferencing mechanism or scanner or computer or whatever be the case, it is being it could be an intelligent one, okay, but it receives and disseminates. Not a kind of powerful coordination is not possible or difficult to achieve in the case of current available technology. Okay, all the switches are distributed and independent, functions completely independent. So sometimes complete independence is will not be beneficial. What we are expecting is a kind of coordination. What we are expecting is a kind of coordination among the switches, among the controllers, among the powerful equipments. then only you can achieve the powerful. Okay. It is almost like having a brain controlling all our organs and other subsystems. So powerful controller is required. That is possible only in software-defined network. Through software, how best we can integrate, how best you can connect all the switches in a logical way. Okay, we are aiming for not physical connectivity. Physical connectivity is already existing. Logical connectivity and logical configuration and logical way of describing the substance is more important. That is completely missing in the existing computer networks. So few limitations of current networks, where enterprise networks are difficult to manage. Enterprise networks in the sense that companies having now the manufacturing trend also changed a lot. Okay, engines are manufactured in one plant. Okay, then their financial operations are handled in different country, and power plants are, assembling plants are available in some other places and so on. So the company itself is viewed into, they are physically, geographically apart. Even if you take Ford or any other organization, probably the assembling mechanisms will be there, but engines are coming from some other country. And the electronic equipments, electronic control boards are coming from different places. So they have different plant. They have different plant, specialized plant. In a very, for example, I can give a very good, wonderful example. The Audi is famous for what is it? Tank. Okay? Audi tank factory is popular, but the control boards are manufactured by foam. The circuit boards and control boards are manufactured by foam. It is a completely automated tank. The circuit boards are manufactured by Bharat Electronics Limited. Okay, they have one plant near Gindi, Nandambakam, and the entire design is being done from Bangalore. Okay, so product is having multiple disciplines. Individual product is having multiple disciplines, and multiple discipline specializations are happening at different places. That is nothing but connectivity or synergism is expected among the different units. So synergism is expected among different units. Okay. Even you may be wondered. So even our few companies are there. Like there are only two popular companies. Okay, engaged in chipset. There are two popular companies engaged in chipset for mobile phone. One is which is a popular chipset available for mobile phone. Tell me a popular chipset available for mobile phone. Intel is a processor. Yes? Processor. Of course, Intel processors are different that is meant for computers. Yes? Yes? Qualcomm. Good answer. So there are two companies. One is Qualcomm and second company is MB. These are the two very popular companies. Yes? MB. That is not that much popular, but both the companies, they are only some. Qualcomm is, you might be knowing about Qualcomm. Qualcomm chipset and Qualcomm communication processors are so powerful, and it is being used in almost all the machines, almost all the mobile phones. You take a Samsung or LG or any other smartphone, you can find the Qualcomm chipset and Qualcomm processor. Okay? Both the companies are located in Chennai. Believe it or not. Gambit is also located in OMR end, and Qualcomm is located exactly in near Perugudi. Okay, they are deciding what the international phone users have to do with the things. Okay, so what I am telling is, so the system, okay, whether it is military application or it is for mobile phone application, the subsystem units are spread across. Subsystem units are spread across. There is a need for connectivity among the subsystems. So which we call it as, conventionally call it as enterprise networks. We call it as enterprise networks, which is mandatory one. Without enterprise networks, company cannot survive. Okay. Whereas handling of enterprise network is not proper as per the current trend. Conventional networks is not good for, not suitable for enterprise networks. They are having their own servers, switches, everything. We are investing a lot, you believe it or not. We are investing a lot, even for college or, might be knowing, the purchase department might be knowing the cost of switches. The cost of currently available switches are, it's available even for 20,000, 45,000, and it is available for 1 lakh, and it is available for high-end prices also. Smarter internet switches are costing 3 lakhs, 4 lakhs, and so on. Okay, even higher. Okay. Of course, SDN controller is costing much higher, because it is capable of controlling all the switches, hundreds of switches. For example, 100 switches means 100 lakhs, 1 crore investment, for which at least we need an SDN switch costing about 15 lakhs. In order to manage all the other 1 crore worth of switches. It is, what I mean to say is, if elephant is there, some person is needed to control. Elephant is so powerful. Elephant is so powerful. It is nothing but various switches are present across the globe, and there is a need for controlling all the switches, all the things in a centralized manner. Otherwise, it will be a waste of resource. Do you agree with that? Okay. So new control requirements are arisen, greater scale and migration of virtual mechanisms. So what we are currently going towards, the technology I told, the cloud computing, virtualization probably might have heard about the subject, as well as virtual machine concept is very popular. Virtual machines are so popular in the sense that for example, your college is having about 500 systems or even more. It's a very big college. Let me take 1,000 students are there and 1,000 computers are given. And if you are conducting a conference or some other program, additional hundreds of students are coming. How to allocate the system? Is it physically possible in overnight to buy 1,000 systems and so on? Not possible. So one solution is having a kind of virtual machines. Through cloud computing, it is possible. Through cloud computing, instantaneously I can assign thousands of computers. But node is required, just monitor is required. If monitor is available, it is possible instantaneously to give a kind of thousands of systems are possible through cloud computing. How is it possible? Through virtualization. So virtualization technique made it possible to visualize hundreds and thousands of systems in a cost-effective manner. So I used to insist, earlier if you want to start a business, lot of infrastructure is required. Now, if you want to start a business on your own, okay, you can get the help of cloud computing, even hundreds of machines in a very short, less cost. Not even hundreds of systems in say 1,000 rupees. Hundreds of systems in 1,000 rupees. You can become a millionaire. But the idea must be yours. For example, redbus.com. Okay, they are doing some simple application. It will be simple or complex, but they become millionaire because of the advantages of mobile phone, advantages of cloud computing also. You can become a millionaire. How is it possible? Cloud computing, through cloud computing it is possible. Without infrastructure, infrastructureless office you can create. But the idea must be yours. Without idea you cannot do anything. Idea is required. Okay. So with the context of virtualization made it feasible and possible and helping everyone. Okay. So now we have been discussing about virtualization of computers, virtualization of switches itself. Virtual switches are there, virtual routers are there. How to easily configure huge networks. This is the challenge. So old ways to configure a network. This is the way the network is being organized. Switches are, these are nothing but switches. Okay. So sometimes if one switch fails, it can be a kind of link, okay, loss in link. It is almost like memory loss. You know how memory loss happens with respect to human being? If some of the main nerve is being connecting neurons are cut, okay? If some of the main veins are neurons cut, so all are neurons. If some of the important neurons cut, then it becomes it can act as a two separate systems instead of coordination. So if one particular node fails, it leads to loss of connectivity. It leads to loss of connectivity. There is no work assignment mechanism. There is no work assignment mechanism. There is no coordination among the routers or switches. No coordination, no work assignment mechanism, no kind of intelligent load balancing, and reliability of the entire network is questionable. Reliability in the sense, if one of the switch fails, there may be a severe loss. Okay. Sometimes before I visited, 3-4 months before I visited Tata Communications located in Bangalore, what they are doing is, they are running optical fiber cable. Okay, optical fiber cable from Bangalore to Chennai, from Chennai to Malaysia, from Malaysia to Japan, from Japan to again they are completely coming around US and various European countries are connected. From European countries to the signal comes back to Bangalore. All are optical fiber communication, completely undersea application, completely undersea communication channel they have actually. They are core channel providers, service provider for government as well as any other private. All the international communications are happening through that channel. So I just surprised. You may not, you may be. It's a very nice opportunity for myself to see such a kind of control. Within this room, they are controlling the entire very good communication network. So with the help of communication network, there is a possibility of connecting the computers and other things and so on across the globe, around the globe. Okay. Some old ways of configuring a computer. So operating system, everything is available. Application, brown color is application, red color is operating system, and blue color is specialized packet forwarding hardware. Specialized packet forwarding hardware available in switches and routers. This is what available or this is what existing. Okay. So limitations. So according to the feature wise, it may all are as I told 3 or 4 disadvantages I told: connectivity, reliability, as well as connectivity, reliability, and load balancing kind of things are missing. Our centralized control is not there. Millions of lines of source code and billions of gates were there in the case of currently available switches and routers. That is why it is becoming so costly. Available for 20,000, available for 20 lakhs. Many complex functions backed into infrastructure. So it is switches and routers are so complex because of the source code and because of other electronic gates and so on. Cannot dynamically change according to network conditions. So dynamism is not there. If one switch fails, it cannot connect to the other end. Dynamism is not there. Okay. So as per the latest definition, intelligence is all about dynamism. Intelligence is all about adaptiveness. Intelligence is all about efficiency in making the data smarter way of sharing the content. No control plane, abstraction for the whole network. It's like old times and there was no OS. See some of the diagrams. It's in 1949. And open an operating system for networks. So what we are looking is a kind of operating system for networks. Currently available is operating system for computers. Okay. OS is available for computers. OS is even if you call distributed operating system, it is all about how best this all the operating system could be distributed. Okay. How best all the operating system could be distributed. That is what distributed operating system or distributed computing in the sense the whole. Whereas now we are going towards operating system for networks. This particular subject will dominate after 10 years. Now you might have thoroughly operating systems and distributed operating system that is required and more essential for you, and including cloud computing. Distributed operating system is essential. Okay. Then there is no exclusive operating system for networks as a global sense. In a global sense, it is not available, and there is a kind of this is a logic behind operating system for networks. This is a logic core idea behind software-defined networking. Whatever I am discussing is all about the current trend, and researchers are working. Various industry people are working towards this particular kind of activity. So now we have, it comes as network operating system. Okay. The idea is to manage network components through network operating system. Okay. What is the need for operating system? Conventional operating system. What is the role of conventional operating system? What is the role of conventional operating system? It was studied that. So various components are connected. For example, in best operating system handles the processor in an efficient way. Operating system handles the processor, processing power, memory power, and storage power in an efficient way. Am I correct? Existing operating system handles processor, storage, and other mechanisms, storing mechanisms in an efficient way. In the case of network operating system, the same way, similar sense, network operating system handles network components like switches, routers, and other channels will be under the control of network operating system. Control programs need to be built. Okay. So network operating system views the entire network in a global sense. Software-defined networking is required for enterprise network. Software-defined networking is required for enterprise network. The purpose of SDN is to integrate all the switches, all the routers to a network operating system. Obviously, control programs will be there. Okay, in order to integrate. The purpose is to integrate all the switches, all the routers, and all the network components together. That way, there is a possibility of achieving a synergism kind of thing. Coordination could be achieved. Network operating system for networks. Lot of protocols were being developed. So if anyone asks what is software-defined networking, okay, this is the where switches and other networking components will come under the control of network operating system, and global network view will be there. Okay. Currently, presently available network, you can suppose if you are applying network neighborhood, it will see it will picturize only the networks in and around. You cannot get a global network view. Sometimes it is mandatory and it is required for enterprise-wide networks. Okay, it is not required for individual user point of view. It is required for enterprise-wide networks in order to handle lot of global, lot of investments in and around. Millions and millions of investments in terms of networking components should be managed properly or could be managed properly only through network operating system also. Just listen and see. So because of the global nature, it is possible to maintain it in a global way, as well as able to write, verify, maintain everything. So all those things are with respect to channel associations. Okay, writing the code. Centralized control is being introduced. Centralized control is being introduced in the case of SDK. Serves as a fundamental control block with a global view of network. Network-wide access control, someone called it like eating. This is one kind of projects happening, and how to obtain. These are the challenges in the construction of software-defined networking, like how to obtain global information, what are the configurations, how to implement, how is the scalability, how does it really work. So the solution is open flow. Open flow is the standard, okay, required to achieve all those things. Enabling innovation in campus networks. Originally it was started for implementing the same thing with respect to a campus. It was started for a campus-wide network, and it is to be enhanced and improved with respect to the global wide networks. The same view should be adopted for the global sense. Hardware drivers were being designed, interface between switches and network OS. Okay, so you know about driving mechanisms, correct? Drivers. So drivers are even for if you are using a stepper motor in your printer, it needs a driver software. Okay, even if you are using USB flash, it requires a driver software. In the same way, your networking components and other things for global achievement need a driving software. That is nothing but hardware drivers need to be constructed. Hardware drivers need to be constructed, which will be capable of managing, which acts as an interface between physical switch and network OS. Physical switch and network OS. In the conventional operating system, your stepper motor or your monitor may be having a driver that VGA and VGA parts. The driver software will be acting as a link between OS and your physical device. Drivers are required for connecting physical device to OS. In the same way, hardware drivers that is nothing but software code that is required for connecting switches to network OS. Hope you can understand. Am I correct? Essence requirement for drivers. Okay? Actually, there are three important layers. Hardware is there, then software is there. What is the third one? Not middle direction. Hardware is there, software is there, and next one is you might have studied in first year computer science, fundamentals of computing. Firmware. Firmware. Okay, there is nothing but software which controls the hardware is known as firmware. Okay, hardware is pure electronic component. Software is pure programs, high-level programs. Firmware is all about software which is capable of interacting and controlling a hardware, directly involving in the controlling purposes, known as firmware. So that is the network. Hardware drivers are nothing but firmwares. So which takes care of control part, data part, control parts for software, data parts for hardware. Okay, because everything is digital data, so it needs to be properly controlled. Okay, meta-study, control part, data part, all those things in multi-processor configuration. Or even in the CPU configuration, meta-study, control part, data part. In the parallel processing, parallel algorithms, meta-study. Data path and control path will be here. So how many channels are required for mobile communication in order to make a single conversation? How many channels are required? How many channels are required for data communication, conversation through mobile? Minimum. How many channels? 3 channels are required. Okay, 3 channels are required. One for uploading, sending, second one for receiving, and third one for control channel. Okay. Sometimes I used to take wireless communication. Through that one day I learned, okay, control channel is also required. You can refer a book called Blake, B-L-A-K-E, Wireless Communication Systems by Blake. There is a very popular textbook, telecommunication as well as electronic communication by Blake, B-L-A-K-E. Open flow controller, open flow protocols are evolving. So it becomes open flow client. Hardware layer. It is software layer and hardware layer with open flow. Various some of the protocols so common. Okay? Or it is matching with the existing protocols. Open flow table entry with the rule, action and state where so action is kind of packet forwarding and encapsulation forward to controller, drop packet, sent to normal processing pipeline and so on. So all the operations are very much similar to the normal switches, active switches or intelligent switches. And it is meant, rules are defined for various applications like switching, MAC, then Ethernet, virtual LAN, IP, TCP and so on, for different applications. So these are the major operations performed: switching, routing and firewall. And it is taken care by the respective protocols. So all the existing networks and setup is same. Only thing is operating system hardware is new. Network operating system is new. Okay. All the available protocols have to be used. Your IP version need not be changed. So existing TCP version is directly usable and useful. Open flow switch, future will be a kind of open flow switch capable of centralized control. So one person is using that work, okay? So through the open flow switch, the person is connected and the signal will be communicated to the controller. From the controller, it will disseminate to the other systems. Okay, global perspective. So if you want to upload the data, for example, if you want to upload the content, video content, okay, you can do it to YouTube. YouTube will receive all the video and other audio mechanisms and so on. After that, the video content will be delivered to dispatch to all the subsequent users. Same way, data is received by the controller and it is being disseminated, distributed to all the other persons available in the enterprise. Simple learning switch, per flow switching and network access control, static VLANs, and their own new routing protocol, unicast, multicast and multipath configurations are possible. Configuring the switches are playing a major role. Unicast, multicast and multipath home network can act as a home network manager and packet process is also possible. And It is called now. It is called as IP version allies. Okay, that person has developed one kind of controller. You can see just need to update your firmware second line. Now the direction is towards centralized versus distributed controller. This is centralized controller and this is a distributed controller. You can see both the things. So centralized control versus distributed control. Now this kind of configuration is also coming up. Both centralized as well as among the enterprise networks how to distribute. In the distributed control, multiple controllers are present, taking care of different open. And some of the switches will come under one controller, few switches will go under the other controller, and overlaps is also possible. Overlaps is also possible. These are some of the switches available in the market. So some of the things are supported by our existing operators like Google is supporting, VMware is supporting, and IBM is going towards that open flow switches, NEC, Cisco and other switches and so on. Now I ask one question. It may look completely different. Who is the competitor for airline industry? Who is the competitor for airline industry? Airline industry is composed of Boeing and the other airline operators and so on. Who are the competitors for airline industry? Yes? To bring your attention, I am asking a question. Who are the threat to airline industry? Who are the real threats to airline industry? Correct, exactly sir. This question was when I am attending a program and one chief MD asked the same question. I thought okay, this for Boeing some other company will be in competition, something like that. But the answer is IT industry is giving a tough competition to the airline industry. Okay, Cisco and IBM and other such people are competitors to airline industry. How? Earlier the meetings were conducted physically. So if some high-end meetings are need to be done, they used to go fly to the other point, and they used to attend, take some decisions and so on. Okay. For example, from this state, the people will fly to the other state or Delhi and have a meeting and come over here. This kind of, because of this kind of transactions or operations, airline industry is gaining a profit. Now, they have come up with Facebook, Twitter and Skype and other various Viber and various WhatsApp and various communication technology have come up, and with the help of SDN also, this is even cloud computing is also there. With the help of all the best communication technologies, now people are avoiding physical movement from one place to another place. Avoiding physical movement, going from one place to another place. In future, even in current trend, I used to avoid going outside and giving a lecture because it is a waste of time for me. Okay, overnight journey I have to perform, giving a lecture for 1 hour or 2 hours, and come back to Chennai is complete nearly 48 hours, 50 hours of time. Whereas now it is possible to through Skype and through other mechanisms it is possible. I prefer attending conferences and other places. Even PhD Viva could be conducted in through Skype. University allows. Okay. So for the airline industry, IBM and Cisco and other popular people are competitors. Okay. Research focus is going towards various definitions and implementations towards the switches, intelligent SDNs. New policies for security are important. Programmable wireless LANs are coming up. Placement of controllers, amount locations and placed on distributed control. Debugger for SDN is also required because of number of lines will be more. Lakhs of lines will be there. Future focuses of SDN: control plane, flow table, state recorder, and source to destination, how it becomes. Okay. Best effort policy need to be adopted. Let us read best effort policy. So with that, I would like to conclude my lecture. Kindly clarify your doubts. You can ask your doubts.
Why use? If it's virtual, why and if it's even?
I told that virtual switches are possible. I am not saying that even if there is a virtual switch, please see that, even if it is a virtual switch, it is a programmable switch. Programmable switch. Earlier they were discussing about physical switches. Later on it migrated from physical switch to logical switching. Okay? Virtual switches are nothing but logical switches and it is a cost-effective switch. But the functionality will be different. Or listen. Even in the case of virtual computers, even in the case of cloud computing, high-end server will be there. Even in the case of cloud computing with virtual machine, it is being done by high-end physical machine and high-end storage. For example, I may be having 1 terabyte of storage or 500 GB of storage space. It is being shared tentatively. So, virtual machine will not replace the physical. Virtual machine is virtual switch is a solution. So, anytime we can instantaneously connect. So, virtual switches are nothing but logical switches designed and operated at higher level. I did not rule out the physical availability of switches and physical availability of routers. Next.
We have access point. We have various access points to the switches.
Yeah.
Like why you said that we have a
So I told SDN is required. SDN is required for enterprise networks, where one is connecting all the switches across the globe, or set of switches across the globe. Suppose if you are running a company, listen. So if you are running a company, you have invested millions and crores. Okay, your company authority might be interested in viewing how the Chennai operations are going on, how the Singapore operations are going on, how the California operations are going on. That is possible only through SDN. Integrating all the switches and having a global view. That is possible only for SDN, only in SDN. Okay. If some of the resources are misutilized or underutilized in Chennai, it can be given to others. Okay. For example, even in YouTube or mail, okay, whenever you are downloading the software, it will ask whether you want to have download from UK or Singapore or Malaysia or Chennai or somewhere. So you will probably click Chennai. If Chennai is so busy, you can get the help from Malaysia. Okay. Switches are fully accessible across the globe, and connectivity is also available across the globe. Yeah, listen. You can ask questions. So the idea is making you to be familiar with some of the technology available as a nearby future. So it may look, sometimes it may look odd. So when you are coming into the workforce, when you are coming as an employee, definitely you will come through this particular type of concepts, and the company will be looking for such kind of concepts. Okay. So you can ask questions. Any other questions? Only women are active. Listen. Men are not active. Am I correct? Why people are not asking any questions? Men are not asking any questions. So Father, we have to celebrate Men's Day also. Correct? So they are celebrating Women's Day and belated Women's Day wishes. So everyone